Today's video we're going to take a look at two USB chargers. One of them is fake, or supposedly fake, at least this is what I'm postulating. And I want you guys to take a good look, guys and gals, take a good look and tell me which one do you think is fake. So you can see both of them have a serial number at the bottom. Let me see if I can get the light in to shine at the right angle. Alright. And the other one as well. Alright. And size-wise, identical. And looking on the bottom, let me see if I can line these up more proper. And the other one is it's quite a bit older, but yeah. And so the reason I'm saying that one of them is fake is the following, and I'll start up the scope for this, and we'll get an image for that as well, and we'll continue with the image on the screen. All right, so now we have one of the chargers set up. Doesn't matter which one. And I have a passive load connected to it, and we'll get the scope on the top right corner. Okay, so first off, let's start with a 20 ohm load, so this should be pretty light. Why have we no image on the screen? Alright, so this is how the signal looks on the top. Let's see if we can get a trigger on that. Is there any period to this? Yeah, there kind of is. Alright, so we have 64 millivolts, like let's call it 70 peak to peak. And if we stop this and we go for some cursors, we'll see that, let me check the period on one of these. Damn it. Alright, so this is about 11 kilohertz. Is it? No. It's just about 6 kilohertz. Okay. 6 kilohertz, 60 millivolts, and we'll turn the cursors off. Okay, so now let's start loading it down, and let's see if the frequency changes or the noise changes. Right, so let's start with a super light load, 250 milli. Let's just go in steps. Let's go 500. And you can see the amplitude did drop a bit, but this is also due to the setup here, so that's not a fault of the actual charger. And we have 85 millivolts peak to peak. Let's just stop it a bit. Okay, nothing super dramatic. Like, I'm not super well versed in this crap, as you can definitely tell, but I'm not seeing any periodicity. Alright, no period. Let's move the trigger into place. Yeah, so that kind of deal. Alright, so let's stop it. Let's get some cursors in. Man, this is super annoying with this scope. Like, do you guys have any idea how to actually do this more properly, the vertical scaling? Because every time I switch the vertical scale, everything gets super messed up and I have to scroll 50 fucking years. So if anyone has an idea, then do let me know. I would be super interested. So let's try and measure one of these. Move the other one. Why, this is so counterintuitive. Oh my god. So we have 132 kilohertz, so this is a completely different frequency. And again, about 70 millivolts peak to peak. Turning it off and maxing it out at 1 amp. Let's move this into focus and get a trigger on it. Getting a trigger on it, you can see the frequency is still 132 kilohertz, so that hasn't really changed, and 80 millivolts on the noise. All right, so let's unplug this this charger. Right, this would be charger A, and let's just plug in charger B. Again, voltage-wise, I haven't actually checked the previous one, but it shouldn't be a big difference, and we're drawing the same current. And as you can see already on the screen, there is some funny business going on. So we'll have to change the scale. So go to 50, and again, like, if anyone has an idea on how to actually, so 0 is the press, right? So it just go to 0, which so I have 3.5 volts to go. 0 wouldn't be better, but man, why does it always revert to a different scale? That's super annoying. Alright, so you can see this looks kind of like this under a 1 amp load, and this is already 350 millivolts peak to peak. Sorry, I moved the cable a bit, but yeah. And frequency wise, let's just check that. So frequency wise, that would be unreadable actually. That is genuinely unreadable. So 53 kilohertz. So half the frequency with a lot worse filtering. And so by now you can probably see why I'm saying that this is a fake charger. Let's actually see it under no load. So under no load, looks like this. Actually, voltage stability wise, I think it is a bit better than the Apple one. Although, so again, almost 200 peak to peak, and no. So yeah, 160 millivolts peak to peak, and let's see what the switching frequency is over here. So now the frequency is 5 kilohertz. Okay, so that also is changing around the place. Let's actually do a rolling sweep and see how it recovers actually. So get this going. Man, that is super noisy. And let's load it down and unload it. Alright, this is also not super great. So let's go 100 millivolts. And again, like, I have to scroll for 5 millennia. Okay, so let's clamp an amp to it and see how it recovers. Okay, so it does actually have some volatility at the beginning. Well, maybe it was the switch. But anyway, what I'd like to see is how far up does this go. So scale is 100 milliamps. Let's just zoom into one of these events. How do we? Alright. So we have what, 100, 200, 300, 400, 500, half a volt. Yeah, it doesn't spike up too high, but anyway, this should be 5.3 volts already. Yeah, that's fine. Let's just call it okay. So super jittery, not super nice, and again 350 milliamps peak to peak. All right. All right. So the time has come to tear down this supposedly fake USB charger. And if it is fake, it will open easily. If it's not, it won't. So let's see how much resistance it will oppose. So I'm kind of being pretty medieval, but do not plan on using this going forward. It is actually sealed very well, so I mean, it's a good fake. I'll give it that. In terms of construction, I really have no complaints. Like, really none at all. This is pretty good. So let's see if this can be hoiked out. There you go. So this will never be, so right off the bat, this will never be doable on an Apple charger, right? You can see there's almost no glue, no no ultrasonic welding of the plastic. I mean, it is okay quality, but this this will not withstand too much abuse. Yeah, this actually doesn't look too bad. Sorry about the nails. I will get those sorted out soon. Hey, you know what? This actually is a very decent copy of an Apple charger. So first of all, we see the flux residues, which I would not expect from Flextronics. Let's see how we can remove the charging port to get a better look at the rest of the stuff. Okay, so now that's off. And again, right, they do rock the cool fake USB adapters, right, which have the writing on them. So that is a nice touch, and it is a must-have touch. I mean, if you're doing fake Apple chargers, you need to have the serial number, which they do. Let me see if I can, yeah, there you go. So they do have that on deck. Sorry about the lighting, it is quite terrible. But I do have some LED strips on the way. So this actually doesn't look too bad, to be honest. So I mean, I'm 99% sure it's not Apple. But for a fake, this is done pretty nicely. I mean, they must have overseen some things, or maybe these caps have gone bad, but I do like it. They're far away from the heat point. I mean, the main one isn't, but it's discharged. I don't know. I'm liking the design, right? Well, what is this? Holy shit! This is a weight. No. No, this is just to match the weights, because I did check it out, right? And it was super similar. Back in the day, they would be way lighter. Motherfuckers, check this out, right? They've heat shrink, but look how nice they heat shrinked it. I mean, I don't know. They're trying to get ahead, right, illegally, but they have done a pretty decent job. I don't know. Damn. Right, so they have this weight inside. Nice. What is this? I don't want to fuck my snips up, did I? No. What even is this? No, it's just some random metal. It's not lead though. So yeah, that was above the chips. What do we have? What do we have? What do we have? Nah, so this is fake, right? We went from 99% to 105% certainty. Confidence is high. Let me see if I can... Alright, so we seem to have an LP3773. So this should be some average garden variety switch mode power supply chip. Right, rectifier capacitor immediately, so power factor will not be great. I do enjoy how they've used 2 small capacitors on the outputs. The shit soldering again. I mean, it's not shit soldering, but it's not pretty. Chickeny cap or Chong X. So even though Apple is cost cutting and shit, I genuinely don't think they're using Chong X caps. But who knows? So separation seems good on the bottom. But they do have stuff going around on the top, so who knows how safe this is, and who knows how safe the inner windings are. Right? They even seem to be potted in something. So yeah, I wonder why it has that noise. Right? I wonder if these caps are bad. Let's actually test these out right quick. So they're supposed to be 270 mic, so let's see if they are 270 mic. Alright, 270, small ESR. Yeah, that actually seems fine. So the caps were probably fine. They just... okay, second one seems fine as well. So they just seem to, right, they didn't use the right components, or they've set up the switching chip wrong, or the topology is bad. I mean, yeah. They didn't give a shit, that's for sure. But it's not the caps, and probably even would have gotten worse over time when these degraded. So I don't know how much of the blow these used to take, right? Imagine if these are out, how bad the noise is now. I mean, we could still check it, but I don't know. Yeah. Okay, so let's actually have a closer look, because this is a bit worse than I initially expected. Right, and so the main problem with the fake Apple chargers is that there is absolutely no liability. So if one of these kills someone, there's no way to trace it back to who made it, right? There's 50 companies pumping these out, right? Whereas with an original Apple one, which for sure came out of the box, right, Mr. Flectronics is going to have some issues if some people die, right? So let's first of all go over the ways this could kill you. So first of all, you simply have it plugged in. And let's say you don't have a socket that would sustain it, support it that well. You just happen to knock it, right? You can see how this absolutely has no problem with this, right? I've even bent the legs, and that is absolutely no problem. Okay, so this could actually come loose, and then yeah, you do have this plugged in, and if you do come and lick this, it will be a problem. Let's assume that you will notice and you will know better, but at 3 years, you will not know better. And technically, right, you touch one of these, you will come away, right? There's no way you can clamp your hands over this. So this technically will, it's tough for this to kill you. You need to fall asleep on it. Okay, second of all, you see all those stories in the news that, oh yeah, this girl was taking a shower with her phone and it killed her and everything. Well, it killed her because she was using one of these pieces of shit, right? This is why it killed her. It's not because, right, a regular Apple one through the USB wire, I would risk my life easily on this, right? But check this out. So let me bring this up a bit higher. See what I can put it on, and we'll have a closer look. So I've depopulated the inductor, the transformer, which again, right, this is another potential point of failure, right? We have no idea how well this is isolated. It does not use doubly insulated conductors on the output, and so absolutely no idea on the tolerances on everything. It seems decently made, but again, no one is afraid that if this will fail, they will have to pay for it, right? No one has to pay if this fails, except, right, the user in the bathtub. So I saw on the back that the separation was good, and it was good, right? I mean, this is decent. I could live with this. However, they have populated the entire underside of the transformer, and some stuff is happening here which can only be described as madness, right? Yeah, so you have to imagine that this has rectified mains on it. So 1.41 times whatever your mains voltage is. So what's this? For my setup is square root of 2 times 225, let's call it. So this has 320 volts over it, right? It is DC, right? So that's a different class of issues, but it is referenced to the mains, right? So live is on this capacitor, right? And the whole idea is you pass it through a transformer which galvanically isolates it. So over here we still have this potentially lethal mains link, right? And it comes this close to the secondary, which is on this side, right? So everything on this side technically is fine. Everything on this side is live. And then we have, right, the output of the transformer has to go through a diode, and then it gets smoothed by these two caps. And then they have this noise suppression capacitor, which again, this is definitely not a Y-class capacitor. I mean, they did mark it as a Y-class, but there is no fucking way this is Y-class. And so the moment this decides to fail, or... Okay, sorry, my phone crapped out. And yeah, so as I was saying, the main problem with this is you are relying solely on this, right, random SMD capacitor, right? Which is basically all that is between you, right, and live mains. And if this fails short, you will electrocute yourself in the bathtub, right? For sure. Alright, so considering all of this, I would recommend that everyone who is not sure that they have picked their Apple charger or their whatever charger, but usually this happens with Apple. If you know for sure that you've pulled it out of an Apple box from the Apple store, whatever, then it's fine, right? You're definitely fine. But if you bought it used, right, and are not 100% that this is an original charger, definitely just rather use a Samsung charger which you know is original, or a Huawei charger which you know is original, something that is original, right? It is super critical. Otherwise, right, this is all that's staying between you and live mains, right? And whatever's in the transformer. So yeah, absolutely careless design, poor performance, right? It could have had good performance, but the risk would still have been there had they went this route. So yeah, anyway. And yeah, this would be the original one, which I will not be taking apart because I am still using it, one, and I am cheap, second. Alright, have a good one, guys.